Okay, today is the 15th of October, and it's time to do a little bit of brush up on the top 20. It came to mind because I was at conferences and I was talking to people about their kids' first 20 scores and how, wow, look at how your kid went from only knowing 10 things to knowing, 18 out of 20. And realistically, when you get an 18 out of 20, it's usually just a couple dumb mistakes at that point. Okay, but then I looked at the top 20 scores. When a lot of people's top 20 scores is like a 7, 5. Okay, because those are a lot harder, aren't they? And I wanted to show you where these top 20 even came from. As you can see, I have kind of a 20 theme. But if you go to Tonka Math Tests, see that one right there? Click on Tonka Math Tests. I own the website tonkamath.com. It's one of my 23 website names. Anyway, so Tonka Math brings you to the same place as where we are right now. But this Tonka Math, like little tab, brings you to the TMT ACT Prep version 1, and click on that, the top one, the version 1. This is what I started with. I didn't start with the first 20. I started with everything that you've learned. This is everything since kindergarten. I figured it out. You've been in math for 1,200 days of math class by now. You've had 1,200 days of math class. Okay? And if you figure that there's 200 things, these are the 200 things that you've learned how to do. There's everything from adding, subtracting, adding negative and positive numbers together, simple square roots. I mean, let's just kind of look through this for a second. This is everything you've learned since kindergarten till now. And if there's 200 things, and actually if you go like this, there's 1,200 days you learned math, and 200 things you learned. That's 6 days per thing that you learned. As in you had 6 days to learn each thing. Do you get that you're now a little bit smarter than you used to be, so you pretty much learn a thing a day? But back in elementary school, it'd be like, we're going to teach you how to add. That's just one thing, but yet you take like 3 months. You know what I mean? Okay, so you're a lot smarter now, so you learn like one thing every day. But this figures that, anyway, these 200 things are the big deal. So like I'll show you one, for example, that's on here that some of you probably wouldn't know how to solve that. I want you to just import this over to Notability now. You know how to open Notability, so you can write on it. And I just want to challenge you with that one. It's not on my top 20. It's not on the first 20. It's different than both. And yet it's something you learned at some point. Well, what can you do with that? Well, you could solve it, I guess. You could subtract n from both sides. You can do that. And you get 1 equals 8. What? Does anybody know what the answer to that is then? Yes. No solution is correct. There is no number that, when put in for the n spot, could ever work. That's similar to, but different than this. What if I said 2n plus n is equal to 3n? Is that an equation? Yes. It said basically 3n equals 3n. When is that true? Always true. As opposed to the other one, which was never true. So this is never true. This one's always true. Or if I write it this way, it'll maybe make more sense to you. N plus 8 equals n plus 8. What's the answer? Well, I could subtract n from both sides, and I get a true statement. If you get a true statement, then the answer is all things work. All real numbers. Anything works. Everything works. Whereas if it's like this, nothing works. All right, so my point is, at some point, you've been taught all of these little things. This memorization section it would be really smart if you memorize this. You know what 10 squared is? 100. How about 11 squared? 121. And a lot of you guys know these. That's awesome. All right. This, if you want to know what everything is, that's the everything list. So when I say top 20, it's the 20 most important things from this list. Top 20 means the 20 most important ones. But if you want to know what all of them are, that's where it is. And there's a key for it too. Okay? So if you want to know everything that you could ever have learned, and maybe you feel like every now and then we get a kid who has moved here from some other district where they're like, I swear we never learned that. Or you could even have come from this district and say, I swear I never learned that, because maybe your 6th grade teacher took a week off because they were sick and you never actually did learn that thing. It's possible. All right. So if you want to know the list of everything, now you know where it is. Okay. Am I going to make you know everything? Nope. But we started with the first 20. And by the way, if this was a lower level class, remember you guys are in honors. If we were in the regular class, I would have started with basic 20, which was even easier than first 20. Okay? Basic 20 is like really simple, like graph y equals x plus 2. You know, like really, really, really easy. All right, we were already done with first 20, and if you're like the kid who still hasn't got caught up on that, well, get your crap together. We need you to be done with that so we can move on to top 20. And we took the top 20, and I totally get you don't have all of them down yet, but I hope you're making progress. Like, for instance, I hope maybe you started with 5, and by now you've picked up 2 or 3 from a friend or whatever. Maybe you just learned from watching me do an answer on the board. Or all right, so I want to give you one of these that I feel like is very learnable, but yet a lot of people don't know it. Number 15. Who in here knows the distance formula? Raise your hand if you got that one mastered. All right, so there's about 6 people out of 30. Okay. If you don't know the distance formula, I'm going to tell you a story, because it's a lot easier to remember a story than it is an obscure formula. So here's the story. Your friend tells you, hey, I found this cool place in Minneapolis, and it's a fight club. And don't worry, you don't have to fight. You can just watch them, but it's really cool. So you walk in the building, and it's this big, long warehouse. And the thing you realize right away is that there's a fight going on right in front of you, but it's not a normal fight. It's a couple of X's. And the giant X is like trying to crush the smaller X. And if it's a fight, of course, that's minus. And they're fighting in, well, nowadays, it's in an MMA, it's an octagon. But in this case, they're fighting in a square. Can you unplug that headphone? You're so intently listening to it. I don't know if you're listening to me or it. All right. Then, as you walk from the fight between the X's a little further back, you hear all this cheering, and there's another big fight going on in the back. What do you think's fighting back there? A couple of Y's. And on your way, you're like, "Ow, dang! I tripped over something." And you look down, and there's a plus sign, a metal plus sign sticking up on the floor. And you're thinking, what? Who puts a plus sign sticking up on the floor? Everybody's going to trip on that. Somebody's going to get killed. They're going to get sued. Well, anyway, that's to remind you. I even forget all the time if that's a plus or a minus. So try to remember. If it was a minus sign, wouldn't it have just been laying on the floor and I wouldn't have tripped over it? Huh? Okay, so plus sign sticking up. And then this is, of course, 2 Y's that are fighting, and they're in a square, old school, like a boxing ring, you know, a square on the floor. Okay. All right, there's the distance formula. Now, if you could picture, if you can tell somebody that story of, yeah, it's a fight, you'll be like, oh, yeah, that means minus. And what do you trip over on the way? A plus sign. All right, so now you know the distance formula. And honestly, human beings are so much better at visual than they are at just abstract things. Like, for example, think back to a movie that you saw. I bet you can, within a few seconds, pull up a scene from a movie. And if you just think about all the things that are in that scene, it would probably take you like a whole bunch of words to describe what was even happening. And yet you probably saw it, if it was a normal movie, you probably saw it for like 3 seconds on the screen, and yet you can picture that in your head. You know what I mean? I could probably picture 1,000 movie scenes right for you right now that I saw once in my life. And I could really describe well movies that I saw twice. And that means a few seconds, 2 different times. And yet I still remember it. You know what I'm saying? So, I'm trying to teach you a strategy of memory here. It's called a mind palace. Sherlock uses this. How many of you guys have watched the TV series Sherlock? Raise your hand if you've seen Sherlock before. Oh my gosh. Then you guys have an amazing treat in front of you. It's on Netflix. Honestly, it is so cool that I told my daughter the other day that new ones had just come out, and she was like, "Get out! Oh my gosh!" Like she was, and I had lied to her, so I was kind of evil. But they only come out with new ones. They come out with 4 new ones per year, 4 episodes, okay, per year. So they take that long to develop, and they're really good. So anyway, you should watch Sherlock, and it's obviously about Sherlock Holmes, and Sherlock Holmes, except in like current day, as in he's driving around in a cab, and not back in the old days where there's horse and buggy and stuff. It's really good. You should watch it. Anyway, Sherlock, even back when the guy wrote the book, this was a strategy. It's called a mind palace. He would go into his mind palace where he was visually put everything in this mind palace so that he can go back to it. He just looks at things very thoroughly, and then he has them trapped in his mind there, and he can go back and look at them. Okay? If you purposely put something into your mind palace, you're going to remember it way better. I'll take a whole different day on this, on my math behind it, but that little story makes it visual. The fact that it's visual means you can remember it better. How many of you think right now, without looking at your notes, you could recreate that formula? All right. And I bet you anything you'll still have it even 2 weeks from now, if you just remember the Fight Club. The key little element would be, you got to remember what you tripped over. What you trip over? Plus sign. Would a negative sign be stuck up high enough to trip over? No, it would have been laying on the floor. Yes?
I do one that's like 4 times x.
Okay, read me which problem number it is, okay?
3.
Problem 3. Everybody look at problem 3. First of all, that's a quadratic. And if you can factor it, you should. But let's say that kicks your butt on factoring. It's just too hard. Then you have to know the backup for quadratics. It's called the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Remember that one? All right. So that's how you solve that thing. X equals negative b, which is negative of negative 14, so 14, plus or minus square root of b squared. Ew, 14 squared? Yeah, it's on my memorized list on the top 202 things. Anyway, what's 14 squared? Somebody knows it. 196. Very good, sir. Minus 4ac. 4 times a, which is 4, times c, which is, what's that number I wrote over it? I can't see it anymore. Is that a negative 8? All over 2a, which is 2 times 4, which is 8. Icky, but true. That's all you got to do. And that square root probably simplifies down to something nice, like the square root of 400, which would be 20. You know what I mean? Something that works. All right. Could there be another answer, another way to do it? Yes, and it involves factoring. Do you get that there's a 2 in all of those? How many of you would be able to do this? Factor out the 2. Is that a skill you have? Raise your hand if that's in your wheelhouse. You could do a true factor out of 2. Okay. Then the next kind of factoring that you'd have to do here is a little more intense. And that's because it has a 2 in the front. But don't let that make it like, oh, I don't know how to do that kind. It's just a 2x and an x instead of just a normal x. You know what I mean? Normally it starts with x and x, right? This just starts with 2x and x. It's not that bad. I want you to take a second right now and everybody factor that. With the help I've given you so far, you can guess and check your way. Hint, this question mark and this question mark have to multiply to negative 4. And the outside and inside need to make negative 7x. Don't say the question marks need to add to negative 7. They don't. The outside and the inside must make negative 7x. So you know it's a 4 and a 1 or a 2 and a 2, right? And you know there's a negative involved. So play around with it until you figure out what combo works. Is it 4 and 1 or is it 2 and 2. And once you are sure, you'll know. You know why? Because you can multiply it out and you'll know it comes out to negative 7x, the outside and the inside. All right, I'm going to pause for a second while you piece that together. It's either 4 and 1 or it's 2 and 2. And there's a negative somewhere. I'm going to pause. So for the people that are still struggling, we're giving out the hint that it is 4 and 1. And you won't know you're right until you've put them in. And you put in a plus and a minus. I'm not saying I did it right just now. I'm just saying you need to play around with those until what? That's the thing people don't know. They get that it has to be those things, but they don't know where and how. So what do you do? Do you know? How do you tell if I've got it right? Like, do you think I have it right now? How could you tell? Okay, so let's multiply it out. If I do the outside and the inside here, I'm going to get negative 2x and positive 4x. Does that make 7 in any world that any of you live in? No, it doesn't make 7. There's no way to make a 7 out of a 2 and a 4. Okay, so maybe I should... Oh, is it even close? No, if it's not even close, then don't switch the signs, switch the numbers. Leave the signs alone. Just switch the numbers. That's a key strategy a lot of people don't know. Now, I've got 8x and 1x. Could that possibly make a 7x? Yes, it could. And I even happen to have the negative in the right spot. Because negative 4 times positive 2x makes negative 8x. And positive 1x put together with that makes this total of negative 7x. All right, so there's my final answer. No, it's not. That's just factoring. All that work was to factor it. This isn't super easy either. Like that quadratic formula, that had nasty numbers in it, but it actually went quicker. This factoring thing helps, but it's not the answer. What is one of my answers? If I got it this far, you should know what the answers are. This has to equal 0. X minus 4 equals 0. So x equals 4. Somebody said that one. Yes. You get what I did there? I made a little tiny bite-sized equation. And now this one. 2x plus 1 has to equal 0. Can you solve that? I hope so. That's just basic algebra. Solve it. Excellent. I still want you to do it. If you need paper, I have paper if your iPad runs out of batteries. Okay. Subtracting 1 from both sides. X equals negative 1/2. Raise your hand if you had that one right. Awesome. That's how you do the hardest one on the sheet. Out of all 20, that one takes the longest to teach. You do have 2 options. That big nasty formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Or factor it out like this and set your factors equal to 0. A lot of people ask, do you have to set 2 equal to 0? Can 2 equal 0? No, it can't. So you don't try to set that equal to 0. Just this part and this part. It's set equal to 0. All right. That's the hardest of them all. And I'm not naive enough to think, oh, they've all got it now because we did a couple practice problems. That's tough. But if you get that down, then when we have a chapter on factoring, you're going to be like, easy. You'll just get straight A's to that whole chapter. Because we have a chapter that involves complicated factoring. The only thing that's hard about it is the factoring like this. And so if we can get that down, which you did at one point, learn how to factor. I know you did. If you get good at it again, that, I don't say this often, out of the all 200 things, factoring is got to be top 5 out of 200 things, being good at factoring. So if you're like, well, I'm not good at factoring, you might as well just say, I'm not good at math. Because from this point on, if you can't factor, you can't really do the math. So if you're not good at factoring, let's fix it. I can make you a master at factoring. You just have to work with me and practice. Come in the morning sometime. Okay, I know some of you suck at factoring. We can fix it. And now's the time to fix it. You're still very young. You have a lot more math classes in front of you. And factoring will help so often. ACT 2. Heard somebody tell me recently on a PSAT test. They were like, "Oh, I realized. I know your favorite thing is if you can factor it, you should." And I realized I can factor it, and then they were able to solve it. And they couldn't solve it until they realized that they could factor it. It's a thing. I'm telling you, it's a really, really powerful one. Out of 200 things, I'd say top 5. I really hesitate to say the number one thing is, but it's up there for sure anyway. Okay, and let me give you one more that it should be a easy peasy. This guy right here, 3/4 instead of divided by 4/9, I'm going to change it to times what? 9/4. And most people seem to know that one. All right. If there's any of these that you need to learn, remember there's a video for each one of them. Take the time, learn them. I'm not going to go through every single one. I don't have time. Okay, and that's the end of the amount of time that I have for today to talk about the top 20. But you need to get these puppies down. It will help you so much this year. And next year, I know because I teach the class you take next year. It's honest pre-calc. This stuff's in there. In fact, what do you think we do on day 2? Instead of giving you the first 20, we give you the top 20. The one you're working on right now. If you can get it mastered now, then you'll know it then too. And it'll help you on your PSAT and your SAT and your ACTs. It'll help you so often. Okay. All right, enough about that. Now, next thing, I want you to go to Schoology and find the file called Transformations Project. I'm going to discuss how you do the project, and then tomorrow and the next day, you get work days on the project, which is pretty cool. So you won't have near as much of me talking at you, except for giving you hints on common mistakes people make in the project. Tomorrow or the next day, you get a lot of work time in class. But you're going to want to start tonight so that you can hit the ground running tomorrow. Okay? All right, so first off, what is this project? It's called the Transformations Project, and you're going to make a cool picture. I want you to go to examples right off the bat so you can see what we're trying to make here. And let's pull up the very top one. Just open the very top one. This is not the best one ever. It's pretty good, though. Does yours have to be this good? No, it doesn't. You can get an A without being this good. This is like crazy above and beyond amazing, okay? But I'd love to be showing one of yours like this next year as an example of like, dang, this kid, that's amazing. All right, so what did they do? What they really did is they took functions and they stretched them and moved them. That's called transformations, right? And they, like, let's look at this one right here. Get this little piece of a function. Do you get that that could be a parabola that's been flipped upside down and moved up? But it stops. Why doesn't, like a normal parabola would just go like this. It would keep going down forever. Why does this one stop? Because we have a domain typed in to Desmos that keeps it from going forever. Well, do you get that this is just y equals x squared except with a negative in front? And what else is it? It's got to be moved up. So what should I do? Plus, and then how far up did it go? It has a number 30 underneath there. So I'm going to say it went up 30. That's really close to it. Now it looks, I don't know if you can tell this, but a normal parabola would be like much steeper like this. So it's wider than normal. Do you get that the kid might have said, well, the thing would have a really narrow face if I do that, so I want to make it wider. That's the math. You go, okay, you want to make it wider? I know how to do that. You go on the inside. And in here, what should you do to make it wider? Add something? No, that would move it to the left. Subtract something? No, that would move it to the right. How would I make it wider? So you'd put like a what in there? A fraction, like 1/8, or maybe like 0.1 x. That would make it wider. You get how you could kind of think this through? And then, how do you get it to stop? Like, this is another really important thing. It doesn't keep going forever. It stops here and here. Well, and if you follow these down, you could say, oh, it goes from negative 40 to positive 40. So here's what you put after on Desmos. that it goes from negative 40 is less than or equal to which variable are we talking about that changes its domain? X. Good. Which is less than or equal to 40. There. Are you going to make this exact person? No, that's not the point. You're going to make your own. But I want you to see how this looks on Desmos. So we'll start a nice simple one. So everybody right now, open up Desmos. And I want to show you something in Desmos that would really save you a ton of time. Or alternately, if you don't do this, it could cause you a lot of pain. It's how to save your project. There are kids who went through and did their whole project, didn't know how to save it, and then when they left the internet and came back to the internet, it was gone. The whole project was just gone. Can you imagine how painful that would be? You want to be able to save it. So right now, we need to set up how to save project in Desmos. Okay? So if you haven't already, get Desmos open now. It says down the app that we're supposed to be download. Download the app. Okay, so you already got the app. I know that because we did that before. If you haven't already got the app, you better hurry up because you're behind. Next, it's to select the drop-down menu. See where it's pointing? Upper left. And do you see the option now where it says create account? Go ahead and do that. Create the account. And what should you use for the email? I would just link it to your minnetonka.org account. In other words, it might make you log into your Google account right now, but just use your regular login 0012435572 at mtka.org, whatever you are, and get your account created. Once you're done with that, I'll do the pause here thing, give you a little bit of time. We'll start playing around with it and see how your project's going to kind of work. Okay, seems like everybody got an account. So everybody type in y equals x squared. Now you have a much better keyboard than I do on my computer. So I'm going to be doing my best, but your keyboard's better than mine. All right, now what if I want this thing to flip? Because it's not looking the way I want it. Let's say I want it to be like a hat or something. So I want it to flip upside down. What should I do? Negative where? In the front. See how it just like, boom, it does what I say right away. So I'm like, oh yeah, that's what I want, except, wait a minute, I want it to be up a lot higher. So what am I going to do now? Okay, so let's make it plus, let's be all the same, plus 5. Oops, I said equals 5, sorry. Plus 5. There. Now, what if I want to cut it off so it doesn't keep running on forever? Wish you could do that to your math teacher, huh? Okay, anyway. So how do I do that? Little scripty things. Find those. They're on your keyboard. This is the base of everything we're doing, so please stay with me. Now I'm going to say it's going to go from -1 is less than. Now if you want less than or equal to, that key's on your keyboard too. X, which is less than 1. Do you get how that contains it between -1, like this, and +1? Now, listen close, because this is one of those super common mistakes. Always do the domain last. That little thing we did in the scripty parenthesis things, do it last. Because guess what happens if I, by accident, make my equation be somewhere so that that domain won't work? Like, what I mean is, if I put in my parentheses and I had this like moving to the left, seven, Where is it now? This happens all the time. Kids are like, it's not there. It's there, you just can't see it because it's not on your screen between -1 and 1. Do you get what I'm saying? I'm going to take off this part now. Oh, poop. I can't. I clicked the wrong thing. Sorry. Can I undo? Oh, yeah, I think you're right. Oh, yay. Okay, awesome. I'm going to arrow over here then. I'm going to delete this part. And there it is. People all the time are like, it's gone. No, you just had the limit. You were saying, I only want to see it between here and here. And it wasn't in there. You get what I'm saying? So always do your domain part last. Because then you'll be like, okay, what's going on? Why isn't it? Oh, I guess I had it moved to the left. I didn't want it moved to the left. Maybe I only wanted it moved 1 to the left or something. Now it's in that little zone. Now I can put on my little scripty things. Between -1 is less than x, which is less than 1. And the scripty things. Okay. Still not what I wanted. Okay, we'll keep playing with it till it is. All right. So what are the rules? Is it just like do whatever you want to make me a cool picture? No. No. You are spending 2 full days in math class on this. It's not just draw me a cool picture. Okay? But what you draw is totally up to you. Here's what the rules you have to follow. There is a list of these too. I'm not just making this up off the top of my head. Okay, I'm going to go back to Schoology and show you in here where you find this list. See project description? If I go into project description, here's a description that says like how many points it'll be, when you have to have it done by, all that good stuff. It does say your image should be something you are interested in, which obviously you are the only one who could determine that. You might make a logo, a character, an animal, an object, or an original design. In other words, even artwork is okay, just like modern art. That's legal. Okay. It just, I'm not, if it doesn't, like, if it really just looks like you just slap stuff down, I'm not going to give it the full points for the artistic part of this. There is a little element of, does it look cool? Okay, so you can make art look cool, but you can also just say, well, it looks cool to me, okay, but you're not grading it. I am. You could get all the points except the artistic part if you just follow these rules. Like, notice it says you have to use parabola. If you don't have a parabola, you won't get the points for the parabola part. You have to use a square root. You have to use an absolute value, and you have to use a circle. Okay? It's not that hard to use all of those. And in fact, if you look in the actual rubric for the project, you have to have 2 of each of those. 2 of everything. It doesn't have to be the exact same size circle, of course. But 2 circles, 2 square roots. And now with new eyes, let's look at that project that we just saw, except let's actually pick a different one. Examples of transformations projects. Here's another one. That is a much more simple and reasonable, like anybody in here could pull that one off. And some of you might be like, those are shapes that aren't on the list. You can add extra things in, like straight lines. Do you get y equals x is just a straight line? If you want to add extra functions in, you can. You just have to have, does this person have parabolas? Find them. Where do you see parabolas in here? If they don't have parabolas, then they don't get the point. They have circles for sure. Hint, that right there is a piece of a parabola, isn't it? So they had a couple parabolas. Does anybody recognize this one? It's a flipped over something. It's a flipped over square root. Circles, of course. What are these V-shaped looking things like that? What's that? Absolute value. All right. Now, one thing, you can't copy any of the ones that people have already done. So you can't do exactly that. You want to make a totally different looking tree, that's fine. Okay, but you can't copy ones that are already on our examples of projects. That's called plagiarism. Can't do that. Okay, so when you're all done, you have to send me the plans for this project. As in, you can't just show me a picture. You got to show me the equations list that gave you that picture. Don't worry, I won't like sell it on eBay or anything. There have been some pretty cool ones that have come in. And if you're one of the lucky ones, we will choose yours. And you can always tell us, no, mine's secret. You can't show anybody ever. But if you make it to our list of amazing, this kid did Steelers Nation. That's his little project. Okay. So just whatever appeals to you, whatever seems cool. And does he have square roots? You see them? Yep. That's these things. Does he have a parabola? See it? Yep. Upside down parabola there. Right side up one here. Does he have circles anywhere? In the nation, the O. Okay. All right. So there's not too many rules. Does he have extra lines that aren't functions? Yes. Anything that goes vertical like this is not a function, but we aren't saying you can't do that. You can add those in because it makes a much cooler picture if you can add in some other lines besides just the ones you have to have. All right, so your only homework for tonight is to start this project. I don't expect you to finish the project by any means. You have 2 full days to work in class, and then it's not due till Monday after break. The 4-day, you guys have a, how many days? Is it a 4-day? Yeah, 4-day weekend coming up. I know you don't want to do this the whole time. That's why if you're really smart, you'll work really hard tomorrow and the next day, and you'll only have like a little tiny bit left. Maybe you'll even finish before the weekend even starts. Okay, that's going to be your only homework. Okay. All right, so look through if you want to, more of the examples, but the main thing is you're going to have 2 of everything, 2 square roots, 2 absolute values, 2 circles. I don't see this kid's other circle, actually. Oh, right in the middle. Okay, there we go. Thank you. I didn't even see it. Okay, try to find 2 of everything. Okay, that's all I got for you for today.